This is lessons 9.4 and 9.5. Today we're going to talk about sine, cosine, and tangent, otherwise known as trigonometry. So first, what is trigonometry? That is the study of this relationship between the side and angle of a triangle. Relationship between sides and angles of triangles. So sine, S-I-N-E, we're going to abbreviate S-I-N, but cosine is the ratio of the like opposite of the angle to the hypotenuse. Cosine, which we're going to abbreviate to COS, is the ratio of the like adjacent to the angle to the hypotenuse. And tangent, we're going to abbreviate to TAN, is the ratio of the like opposite of the angle to the like adjacent to the angle. So notice we're using opposite, adjacent, and hypotenuse as our three sides. So we're going to call this SOHCAHTOA. SOHCAHTOA. So sine is opposite over hypotenuse. That's where our SOH comes in. Cosine is adjacent over hypotenuse. That's where CAH comes in. And tangent is opposite over adjacent. That's TOA. So we're always going to do it for one of the acute angles of the triangle. We're never, ever, ever going to do it for the angle of the triangle. So for these three, if I wanted to list out the tangent over for angle A, I'm going to go ahead and circle angle A. I know that C is the hypotenuse in the center. And then if I look at the cross or opposite angle A, that would be this side is opposite, and the remaining side is adjacent. So sine, I'm going to write SOHCAHTOA up here again. SOHCAHTOA. The sine is O over H, so it's going to be A over C. Cosine is A over H, so that's going to be B over C. And tangent is O over N, so it's going to be A over B. At the second triangle, I want sine, cosine, and tangent according to angle B. So the hypotenuse is going to change, but now if I want to know what's opposite B, that's different than what was opposite A. So sine is now going to be B over C. Cosine is going to be A over C. And tangent is going to be B over A. So if you notice here, for the two angles, the sine and cosine actually switch. So sine of A is actually the same thing as cosine of B. Cosine of A is actually the same thing as sine of B. So now let's do it with some numbers instead. We want sine, cosine, P, but we're just going to leave it as our fraction. So here's P, by hypotenuse, opposite, adjacent. So for sine, O over H is going to be 15 over 17. Cosine, A over H is going to be 8 over 17. And tangent over A is going to be 15 over 8. So you can go ahead and try this next one, right? Sine, cosine, and tangent of R. Pause when ready to the answer. All right, so for sine of R, I got 16 over 65. For cosine of R, I got 63 over 65. And for tangent of R, I got 16 over 63. So notice when I'm doing sine and cosine, I'm always going to have the smaller number on top of the bigger number because in sine and cosine, the bottom number is the hypotenuse, which is always the biggest side. But here, tangent of R, I had 16 over 63. And in my previous one, I had 15 over 8. So tangent doesn't really matter what's bigger or smaller because it's just opposite over adjacent. So it could be bigger than 1, but it could also be less than 1 as long as I'm doing O over A. All right, using the calculator. Over the years, you may have noticed that your calculator has buttons that say SIN, COS, and TAN. So these stand for sine, cosine, and tangent. For our purposes, we need it to be in degree mode because we're dealing with triangles that have angles measured in degrees. So if your calculator is not in degree mode, which usually happens in a graphing calculator, and usually not scientific calculator, you have to switch it to degree mode or else none of your answers are going to make sense. But what it does is your calculator has whatever the sine, cosine, or tangent is of that angle stored as a decimal, all right? So on our calculators, I would click the sine button and then 53 and hit enter. If I do that and run the 63, we get 799. We do the same thing, cosine of 65. We should get 0.483. If I do tangent of 32, get 0.625. All right, I'm going to pull up a calculator for us if you give me a second. All right, so this is a graphing calculator, so I'd have to make sure my mode was in degree mode. Notice how it says radian right now, so I'm going to go over to degree. And now I have my button sine, cosine, and tangent right here. So if I had hit sine and then 53, I got the 0.7986, and I said that was 0.799, right? If I did cosine of 65, that was the 0.423. And if I did tangent of 32, that was our 0.625. All right, so you're going to go ahead, try the next three, make sure your calculator's in the right mode, round them to 3 decimal places. Pause when you're ready to see the answer, hit play. All right, so check your answers here. Sine of 60 should have been 0.866. Cosine of 45 was 0.707, and tangent of 74 was 3.487. Is I can find this inside the right triangle if I know one of the sides and an angle in the triangle, because I can then figure out, do I have sine, cosine, or tangent? I could find that value on the calculator for the angle I have and set it equal to the fraction I know for sine, cosine, or tangent. So our first step in any problem, if I'm trying to solve for a missing side, I'm going to start with the angle they gave me. The acute angle. We're never, ever going to learn the right angle, the acute angle. So for this acute angle, I know that 19 is my hypotenuse, and this is my opposite side. This side was an vacation. It's not actually part of our problem, so we don't need to worry about it. So if I look at TOA, and I see that in my answer, I have labeled O and H. Of these three, I see O and H there. Means I'm going to set the problem using sine. So it's only going to be sine of the angle we know equals, and now I'm going to set O over H, or X over H. I'm going to use the calculator to find the sine of 28. So we're going to hit sine 28 equals, and I get a decimal. So I know that decimal equals x over 19. To get x alone, I'm really going to multiply by 19. So on my calculator, I'm just going to hit times 19. So when I hit times, it kept answer. It knew my previous answer. And I get 8.9 as my final answer here. So x equals 8.9. So when I get the sine of that, even though we've been rounding cases before, I'm actually going to keep the whole thing in the calculator and then just do whatever has to be done in case it was multiplied by 19. All right, next example, here's our angle. So this side would be the hypotenuse, this is opposite, this is adjacent. So I have O and A is tangent. So tangent of 41 equals O over A, x over 32. So we're going to find the tangent of 31 and then times it by 32. So tangent of 41 times by 32. And we get 27.8. All right, let's keep it going here. We have quite a few examples to try. Okay, here's our angle. This is our hypotenuse. This would have been opposite. This is the case. So out of SO, TOA, A and H is cosine. So cosine of 21 equals A over H, or X over 26. So we're going to find the cosine of 21 and multiply it by 26. Find the cosine of 21, multiply it by 26. So that's 24.3, we'll say. All right, I'm actually going to skip the next example because it's a little repetitive and I did it behind here. So I have my angle. This is the hypotenuse here, and this is the opposite. So O and H is sine, right? So I'm going to put sine 33 equals O over H. This time it's 15 over X. So when I find the sine of 33, I'm no longer going to times by 15. What's really happening is I'm timesing by X, technically. And then I'm dividing by the sine of 33, or whatever decimal that was. So in my calculator, when I find the sine of 33, I'm really doing 15 divided by that. So I have two choices. I could either find the sine of 33, get an answer, and now hit 15 divided by, and every calculator has an answer button, so it knows the previous thing you put in, and we get our answer there. Or I could do 15 divided by sine of 33. All right, so it's up to you if you want to find the decimal first and do 15 divided by the answer, or just right away do 15 divided by the sine of 33. Either way, we get 27.5. All right, example 6 here. That would have been O, and this is A, so this is Kaya. So cosine of 43 equals 36 over X. So we're really doing 36 divided by cosine of 43. 36 divided by the cosine of 43. And we get 49.2. All right, so the first part of each problem is really figuring out which ratio you're going to use. Is it going to be sine, cosine, or tangent? The second part of the problem that we need to do is know, are we going to be multiplying or dividing? All right, example 7 here. So we're using TOA. So tangent 72 equals 25 over X. This is again going to be 25 divided by the tangent of 22. 25 divided by tangent of 72. And we get 8.1. All right, so number on the bottom is going to be multiplication. And if it was number on top, we're going to divide. All right, I'm going to skip the next example, and you can go ahead and try a set of problems. All right, find the missing variable, round to the 10th, pause. When you're ready to see the answers, hit play. All right, let's check over these answers. All right, if you need more time, pause the screen so you can check them. Otherwise, we're going to move on. So the last thing we're going to talk about today are the actual applications of trigonometry. So we have things called the angle of elevation and the angle of depression. So when someone's looking up at something, so you're standing below and you're looking to the top of something, that's called the angle of elevation that's being formed. So when we have the horizontal line, it's on the bottom of the triangle and it's the angle going up towards the top. Whereas the angle of depression, when I'm looking at a horizontal line and I'm looking down at something, it's the angle formed there. Sometimes it might look like it's even outside of the triangle we have formed, like it shows in our picture here. What we do need to know is that the angle of elevation is actually exactly the same because they're all interior angles. So if you're given the angle of depression, we can actually transform it to the angle of elevation. The most important thing to know is it's never going to be the top angle here of a triangle. All right, it's only going to be the ones formed with horizontal lines. So here's our first application. Casey sites the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. How far is he standing from the base of the lighthouse? So we know that the lighthouse is 84 feet. We know the angle of elevation, so the angle at the bottom is 58 degrees. And we want to know how far is he from the base. So he's here, we're looking for that. So I have my angle, O, the right angle, A. So O and A is tangent. Tangent 58 equals 84 over x. So we're going to do 84 divided by the 58 and I get 52.5. And our answer would be that in terms of feet. All right, the next problem, a lifeguard is sitting on a platform looking down at a swimmer in the water. The lifeguard stands 8 feet above the ground. So the lifeguard 8 feet above the ground. And it's an angle of pressure. I'm looking at a line like this. And that is 8 degrees. How far away from the swimmer is the lifeguard? The swimmer's here, the lifeguard's here. So we know that this 18 would be the same as this 18. So with this angle, that's O and A. This is actually another problem. Tangent 18 equals 8 over x. So we're going to do 8 divided by the tangent of 18, and I get 24.6, and this is also in terms of feet. All right, third application. Leah's mom is standing at the bottom of the slide, playground, waiting for Leah to slide down. The angle of elevation from the bottom of the slide to the top is 46 degrees. So they're telling us we have a slide. The angle of elevation is 46 degrees, and the slide has a vertical height of 9 feet. We want the length of the slide. So this is actually the slide here. So we're looking for the length of it like that. So O, each, we now have sine. Sine of 46 equals 9 over x. So 9 divided by sine of 46, we get 12.5, and this is again in terms of feet. This last application is a little different because it's not talking about an angle of elevation or angle of depression. We have a wire attached to the top of a 30-foot pole. Wire attached. With the graph. The angle formed by the wire and the pole. So this is the pole, this is the wire. This is telling us this angle is 8. What is the length of the wire? So this is actually a little different because it is an angle, but it's not the angle. So this is a times cosine of 38 equals 30 over x. So that's 35 over 48. And we get about 1.8. So you're going to try the final two. Pause it when you're ready to see the answers, hit play. All right, so for the first one, we would use tangent of 17 equals x over 131. So I'm finding the tangent of 17 and multiplying it by 131. I get 40.1 feet. For the second one, you might have had your picture look a little different, but we should have used tangent of 73 equal to x over 1200. So we're going to find the tangent of 73 and multiply it by the 1200, and we get about 3,925.0 feet. And that is sections 9.4 and 9.5, learning about trigonometry, sine, cosine, and tangent.